Okay, so picking up where we left off, so we've talked about recognizing when we had this form, so now this guy right here, the integral of 1 over the square root of a squared minus u squared du is always going to integrate to sine inverse u over a. So I look at that, and that's not even close until I look inside here. That my radical, 1 minus x to the fourth, could be rewritten as 1 squared minus x squared squared. That I can make, let's put it this way, that I can make inside the radical the form a squared minus u squared. That I might be able to do that. And that makes me think sine inverse. Let's write out sine inverse or inverse sine. And we're going to try to make 1 over a squared minus u squared du, which then integrates to sine inverse u over a plus c. Okay, let's see if we can do that. So the 5 and the 3 can come out. I can't take that x out. You can't take variables outside of the integral sign. So there I did a little bit of rewriting. Okay, we're trying to make a squared minus u squared inside that radical. I got the a squared, happens to be 1 squared. I want to create u squared. So I have x squared squared. So if I let u equal x squared, that's then going to make du 2x dx, and then do that quick check. For this to be working, I need to see that variable part. Du is 2x. The 2 will take care of itself. X. I need to have an x in the problem, and there is an x in the problem. And that's one of the things you want to start thinking about, that when you make these substitutions and you calculate du, whatever variable part is sitting in the problem, sitting in du, needs to also be sitting in the problem. 2x, there's an x there, and I got x in the problem, so this is working. Then solve for dx, and dx is du over 2. And so make the substitution. There's u. Dx is du over 2x. I get some excellent canceling. The 5/3 can just stay. That 2 in the denominator can come all the way out in front. You can take out multiplied coefficients, not variables. And otherwise, I have 1 over 1 squared minus u squared du. And then we can use that the integral of 1 over a squared minus u squared du is sine inverse u over a. And so I get 5/6 sine inverse, very technically, u over 1 plus c for 5/6 sine inverse, and then u was equal to x squared. And so u 5/6 sine inverse x squared. I don't need the over 1. And we did it. And again, it's about recognizing forms. That once I saw there was potential for making a squared minus u squared, I thought about, can I really make this sine inverse? And can I really make this happen? And I was able to, and so I was able to integrate with sine inverse. Okay, next one. And you could check that by differentiation, but we don't want to be here all day. Okay, the last thing that we haven't done here, we've kind of covered most of these things. We haven't covered all of them yet. The only one, yeah, we have covered all of them, honestly, except this last guy here. Because we don't know how to yet integrate natural log of x, sine inverse of x, or tan inverse of x if one of those previously mentioned functions is present, let u equal that. Now that's not an always, and I've already said that there isn't going to be an always in integration. There's just things that frequently work, and then we hope. And so this problem. We don't know how to integrate sine inverse yet. That's Calculus 2 topic. So since we have no hope of integrating sine inverse in Calculus 1, we need to get rid of that. So we don't know how to integrate it, and we aren't going to learn how to directly integrate sine inverse in Calculus 1. That's Calculus 2 topic. And so one of mathematicians' favorite tricks, if you see something you don't want to work with, try doing a substitution to get rid of it. And that is a very common mathematical trick. I don't want to work with sine inverse. It's too hard. So can I do a substitution and get rid of it? And notice it is an inside function. Now I have two inside functions, so let's try something that is wrong first. If I go u equal inside, I do have two inside functions. I got that 1 minus x squared inside that square root, which would make du negative 2x dx, but there is no x in the problem. It's not working. So let's try again. And again, let's let u equal the inside. And so u, this time I'm going to go for sine inverse of x. Calculate du, and you're just going to have to remember these, that the derivative of sine inverse is 1 over the square root of 1 minus x squared dx. That's in the problem. I got a square root of 1 minus x squared in the denominator. And I got a 1 minus x squared in the denominator over here. Solve for dx, and dx is then going to be square root of 1 minus x squared du. And so then doing the substitution, that's going to be u. dx is the square root of 1 minus x squared du. Absolute great canceling. That gives me u cubed du. That's entirely in terms of u, so I can proceed. And so 1/4 u to the 4th plus c. For 1/4 sine inverse of x to the 4th plus c. And we integrated it. And again, you could differentiate that and it would check directly back. So again, that's kind of one of mathematicians' favorite tricks. If you see something you really don't want to work with, see if you can make a u substitution. But it has to actually work out. This worked out because when I let u equal sine inverse and I calculated my du, it was in the problem. Square root of 1 minus x squared in the denominator, square root of 1 minus x squared in the denominator. Okay, that's step 5 that I keep saying, it's not going, we haven't done it. Let's finally do one. Okay, so let's do one. Okay, got an inside function, cool. So let's let u equal the inside function, which will make du, oops, well, we need to actually write that down, don't we? So u is going to be x minus 1, which will make du just dx. I mean, there's a dx in the problem. I don't need to solve for dx, because it's already solved for. So that's going to be u. Dx is just going to be du. And so step 4, I get x squared over u to the 3/2 du. There is still an x. Still a factor containing x. And so I cannot proceed, cannot yet integrate. We need the integral entirely in terms of u. Now, what a lot of people do is they will just factor out that x squared, and that's just completely, totally wrong. You cannot factor out variables. What we're going to do instead is this. And so step 5. Using that u equals x minus 1, solve for x. And when I solve for x, that would give me x equals u plus 1. And substitute again. Meaning this, that I was here. I had x squared over u to the 3/2 du. Well, I now know what x squared is. I know what x is. X is u plus 1. Quantity squared over u to the 3/2. That x was u plus 1. And now it is entirely in terms of u, and we need to decide what to do next. Now, unlike the simpler problems we've been doing, this guy isn't ready to go yet. But we can simplify. And so that's what I'm going to do. I'm going to simplify this guy. So on the top, foiling that out, that's going to be u squared plus 2u plus 1 over u to the 3/2 du. Then we have one term in the denominator. And what frequently works there is to split it up. Again, there's not going to be an always. And so u squared over u to the 3/2, 2u to the first over u to the 3/2, being very explicit, then 1 over u to the 3/2 du. Then keep simplifying, subtracting my exponents. 2 minus 3/2 is 1/2. 1 minus 3/2 is negative 1/2 plus u to the negative 3/2. That when I'm dealing with exponents other than 1, forget what I just said, I want to get rid of my fractions when I can, with the exception of 1 over u and my fractions that lead to tan inverse and sine inverse. Otherwise, we need to get rid of all fractions. So I got rid of my fractions. Again, the only 3 fractions you want, 1 over u du, the fraction that leads to tan inverse, and the fraction that leads to sine inverse. And we will finish this guy up on the next video.